Yep. I bet you they were upset. Okay, we are on number 18, which is a language problem, and that's not anything to be worried about because these are just applications that are used. In 18, I'm going to read it. The size p of a small herbivore population at time t in years obeys the function of p of t equals 500 e to the 2600s t. If they have enough food and the predator population stays constant. After how many years will the population reach 1,000? All right. So 1,000 is the population, and they're wanting to know t time. Is that true? Okay. So this is p of t is 1,000. All right. So we're going to insert that 1,000 equal to 500 e to the 2600s t. To get rid of e, we're going to multiply natural log to both sides. Ready? We're going to undo e by making everything a log after we divide by the 500. Is everybody comfortable? Okay, so we're going to first divide by that 500. So we're going to get 2 equals e to the 2600s t. We're doing natural log. So that natural log of 2 equals natural log of e to the 2600s t. These are in, if I could get my color to work. I think my pen is just about dead. Sorry. They'll cancel that, not this, but the other. So now I have ln of 2 equals 2600 t. Now we're looking for t, so we're dividing by the 2600. And this is approximation. So we're going to use our calculator to come up with a type of answer. ln of 2, make sure you close the argument, divided by, and this is 2600s, and I know you see the decimal. And we get and they want it in after how many years? So we're talking approximately what? 2.7 years? Or we could say 3 years in this case sometimes. But I think that's what they wanted, 2.7. It didn't say to one decimal. Yeah. And oh, yeah. I know. I will, when I grade this, I will definitely put in how many decimals I want. Is that okay? Yeah. I just noticed that because they did 2. How did I know it was 2? Nowhere did it say 2. And time, it's time. I would have said 3. And it covers for certainty. But hey, what do I know? Okay, nothing. Okay, we're on 19, and this is bacteria. The bacteria of a container quadruples, that means 4 every day. And there's initial 100. Bacteria. I know, right? I think that's so bizarro. I don't know. Like I said, I will make sure if I put that problem that we'll have a good thing. I promise. Okay, now they said quadruples in hundred with a star. Okay, it says write an equation that models the number of bacteria after D days. Okay. And then it asks how many bacteria after 1 week. But we're going to just take this first. Well, the model for this, it's a growth, right? So we're talking bacteria in days is equal to, and we're started with 100, and we're multiplying times 4 to the days. Quadruples 4 every day. Okay. Okay, so we want the number of bacteria after 7 days. It's going to be a scary number. Well, 1 million. Yeah, that's a bunch. Okay, this next one, we're talking about if S denotes the length of an arc of a circle of radius r suspended by the central angle theta, find the missing quantity. So this one is the beginning of that geometry that we did. So we have arc length of any portion of the circle is what? And they want length. So we're talking about 2 pi r. I think that's it, right? I didn't write my formulas. Let me look that up before I give you the wrong one. Well, that's fine. I'm just getting the formula, making sure it's in degrees. Yeah, theta r. Just making sure. Sometimes my memory, because I know I know that the 2, so it's theta r, and theta is in degrees. And they gave us 10 and 6700ths is r, and theta is 2 and 9 radians, and that's what we need. So what is S? Oh, we just multiply. I'm sorry. Sorry. That's all we're doing. Got to make sure of the formulas. And remember, I'll be giving you the card that you can use for our exam on Wednesday in centimeters. And they wanted it in our answer. That's what I got it in the math, which I think is a good answer. I don't know. What do they want? What is this one? 20? Yep, they just want 1 decimal. I'll make sure about the decimals. Wednesday, I think. Unless you're graduating and I need to know. Me too. I thought it was Monday. I'll look. Make sure. Yeah, May 5th is ours. It's Monday. Yeah. I thought it was. I thought I mentioned that. Okay. And I have another one where the radius is 2/5 feet. S is given, and we want theta. So in this case, we have 16 equals 2/5 and theta. And multiply by reciprocal, which is 5/2. And this goes in 8. It looks like 40. And it's, of course, in radians. All right. All right. Now we're at 22. 22 is for a circle with a radius of 4 feet. Find the arc length of a suspended arc length S, suspended by a central angle of 30 degrees, round to the nearest hundredth. Okay. All right. Arc length. I don't remember that formula either. Sorry about that. It's the same one. Let's see. Yes. And we have to change this to radians. Because the formula has to be in radians. And we know this is what? Pi 6. And we're doing an approximation. Yes. It's not 9? Oh. Well, like this 4 is 22. Radius is 4 feet. Find the arc length. It's 9.
Right. It's not 9. It's 4. Yeah. So it should be 4 times pi. R equals 4.
Oh, okay, gotcha. All right, sorry. Man, thank you guys. Oh, yeah, okay, got you. Well, see, you're all are set. I love it. Okay, let me clear that. So I'm going to do 4. There it is. Thank you. That's the answer. Okay, now let's see where I'm at. Convert angles to express with pi to radians. So we know the proportion. We know that pi is equivalent to 180 degrees. So we're going to say, what is this at 75 degrees, right? What is that? What is that? 75 divided by the 180. Math frac. 5/12. And then we have that 24 is 87 degrees, 2 radians. Oh, I have it backwards. And I want pi over 180 times the 87. And that is 87, what is that? 15, it's divisible by 3. 87 divided by the 180. Math frac. 29/60 pi. Okay. Then convert angles to in radians to degrees. We just flip it. And so that'll give me 180 divided by 4. And that is what is that? 45. I could have guessed that one. I don't know why I worked it up. Oh, and I can guess this one too. Pi 6 is 30 degrees from our unit circle. All right. Okay. Let me do 27. 27 says A denotes the area of a sector of a radius r formed by the central angle theta. Find the missing quantity if necessary, round to 2 decimal places. So r equals 4 feet. Area equals 58 feet squared. So we want theta. All right. So in this case, we're talking area. So it's radius squared, and theta is in radians. Yes. Sector. There's a consideration on what portion of the sector this is. So let me get exactly what I need, because this will not give it to me. Let me do that. Yes, I have to do theta over 360. I was saying, because we're doing a sector here. Yeah. And it's in degrees. All right. So we're talking degree. All right. So what we have here, I'm going to rewrite it. 16 pi over 360 theta. Does everybody agree? Everybody agree? Okay, because I'm going to multiply by reciprocal. So this is my numerator divided by my denominators. Everybody comfortable with that? Okay. I mean, when you see me put it in the calculator.
Chapter
6, 7, 5, 6, 7. We did 6, 7. No, I know it's 6 and 7. Yeah, it was 5, 6, 7. One of those. Well, it's been a while. Two. Okay. We've got. I followed the homework. It's been a while though, hasn't it? It doesn't ring a bell to you. Okay. Well, if it doesn't ring a bell, I'm not going to include that one or that one. Okay. An object. How about this one? I did linear speed though. I know I did linear speed. Did I? Okay, I'll look that up. See if I'll make sure. Okay. I mean, yeah. Well, it's okay. We'll check on 27, 28, 29, and 30. And these we know, the next ones, because these are law of sines and cosines. That's what we're getting into. Yeah, it's 7. This one is 7. This was 5. The one we just did was 5. I might not have covered all of that. I just looked at what I thought I should do. Yeah, you're probably right. No, yeah, I might have not covered that particular section in 5. I had so much I wanted to do. Okay, here we go. Two sides of a right triangle, ABC, are given. Find the indicated trig function that gives the angle. Give exact answers with rational denominators. So we have, it's law of sines. We have a sine A. That's what we want, sine A. When A equals 7 and B equals 9. All right, so we're saying we need, oh, well, this is cosine, isn't it? Oh, no, it's sine, but I don't have sine. Sine A, they want sine A. Oh, okay. We just need trig. So we want this angle. So that's opposite over adjacent. So, or we could just do Pythagorean theorem. Sorry about that. Right? Okay. Or inverse sine. Oh, let's inverse tan. Let me read that again before I give you a wrong answer. Find sine A. Okay. Then that we need Pythagorean theorem first. I thought they wanted the angle size, and they don't. And we know that sine A is opposite over hypotenuse. That's all they want. So we have to do Pythagorean. I've got to get the C. So it's 7 squared plus 9 squared equals some C squared. Sorry about that. 49 and 81. So this guy here is 130, right? 10, carry the 1 is 9, 130. All right. Square root of 13 and 10. That's what it is, I guess. Okay, so opposite is 7. 7 over the square root of 130. So that gives us 7 square roots of 130 over 130. If I did the math right. What did it want? Did anybody look it up? That one is, what did I just work? 31. Yep, that's all they wanted. All right, Pythagorean theorem. Now we did that. Okay, we're gonna do 32, which is find the sine b when b is 7 and c is 8. B is 7 and C is 8. And they want sine of B, right? Angle B. Well, that's opposite over hypotenuse. It just looks like 7/8. That's what it looks like. Let me look. Is that what they have? Well, that was too easy. Definitely not going to put that one. I'm telling you, because that's what I'm saying. It looked too easy. Oh, no. Oh, you think so?
I think all of them should be just like that.
Oh, just like that.
You definitely have to know what the opposite and what the hypotenuse is.
Yeah. Oh, yeah. Okay, the sine of theta is the square root of 7 over 4, and the cosine of theta is 3/4. All right, and they said find tan. And they want us to use identities to find exact values. Okay, so tan of theta is sine of theta over cosine of theta. So we're going to enter the square root of 7 over 4 over 3 over 4, which gives us, when we do the cube change flip, square root of 7 over 3. And I'm thinking that's the answer.
Wouldn't that triangle not be possible?
I don't think it is, but they just asked us to forget it.
The hypotenuse is fine. That's right. That's not what
They're not asking. It's almost a flat, and you're absolutely right, because it's very high, and this guy is long, and there is that it is what do they it's not an obtuse angle, but it is not possible,
you're not asking to solve. You're asking for.
because it'd have to be 1, and I don't think we can get a longer one to 1, because I don't know. It's a weird triangle. Anyway, they just wanted us to construct. And thank you for that. I'm glad you're that astute. Okay, we have given the sine of theta, described as 2 square roots of 2 over 3, and the cosine of theta as 1/3. And we want to find cosecant theta. So what is cosecant theta? It's a reciprocal of what? Cosine of theta, isn't it? Secant is sine.
Right.
Cosecant, no, is this sine? This is sine. Sorry.
Yeah, there you go.
There we go. I got brain freeze. Okay, so it's a reciprocal of that guy, which is 3 over 2 square roots of 2, We're going to multiply by the square root of 2 to rationalize the denominator. Yeah, I'm pretty sure. Okay, just had a brain freeze somewhere. All right, now 35 says use definitions or identities to find the exact value of the indicated trig function. All right, I'm going to stop the video here.